Hey guys, Mr. Odell here. This is our first physics video in our asynchronous video trial. Sorry, cat's hanging out with me. So anyways, we are going to give this a try. So what we're going to do is we're going to have a YouTube video that gets posted the day before our Teams meetings, and we're going to use those Teams meetings to treat it as office hours, let you ask questions or talk about assessments, and maybe treat it as a place where you guys work a couple problems. That way you can get them checked by me, or work it as a group, and then from there you guys will be free to go, because I think that's a little bit better than having to show up for a lecture. Hopefully you guys like it. But anyways, we're going to jump right into it because you guys, I'm going to try to keep videos to about 10 minutes just to make it a little bit easier to buffer for those of you that have bad internet. So let me shrink my camera here and we'll get going. So our starter. So what's the difference between a vector and a scalar or a non-vector? So go ahead and pause the video. Take a couple seconds, try to come up with the answer. So at this point, you should be unpausing the video to try to answer this question. So the difference between a vector and a scalar. So scalars is a quantity that has a magnitude or size and has no direction. So an example being speed, so I'm going 5 miles an hour. A vector, on the other hand, is a quantity with both magnitude and direction. So I'm going 5 miles per hour to the east. So notice that distinction. And our first lesson back, we're just looking at reintroduction to vectors. So whenever we're talking about representing vectors, there's a couple of different ways you can do it. So in physics, we typically represent quantities with symbols. So our example being, we use t for time or delta t. Either is fine. So vectors can be represented in a few different manners. We're going to use speed and velocity as our example because both are values that you've learned already. Speed would be represented by a v. I think it's technically a Greek letter. I can't remember the name right now. It's easy to type as an italicized v. So my vector can be represented as a boldface version of the variable. So a bolded Greek letter. Or we can write an arrow above the variable. PowerPoint doesn't let me represent it, but I'll show it in problem sets if you guys have questions. It's literally just a V with the arrow over top. Similar to like if you see like V bar with the line over top of something showing the average. So, but instead of the line, it's an arrow. So vectors can also be combined. So we can take the sum of two vectors, and the sum of that is called a resultant vector. So in order to get a resultant vector, the vectors have to have the same unit. So I can't add a displacement and a velocity, which makes sense. So, and you guys have already done this because we've added vectors before whenever we talked about direction. So positive and negative values, right? Because we talked about like a train moving 30 miles per hour to the east, and then the train then moved 15 miles an hour back to the west or something like that. So you guys have done this. This should hopefully be pretty easy. We're just expanding on it a little bit into the 2D realm instead of the 1D. So I realize this slide probably a little bit confusing looking at it right now. So vectors can be added graphically, and graph paper is super useful for this, but if you don't have graph paper, drawing it freeform is perfectly fine. So we see a couple of different examples. So looking at our top row, we have our first one on the far left is showing my vector A. My second one is showing vector B. And my third one is showing A and B. So what happens is I draw vector A, and then from the tip of vector A, I can draw vector B. And my resultant vector, or vector A plus B, is going to be from the tail of vector A to the head or tip of vector B, because I moved vector A and then I moved vector B. Hopefully that makes sense. So other images on here on our second row, instead of doing A plus B, we can also do A minus B, and we'll talk about that a little bit more in depth. And my last one is showing us using scalars to multiply values. So notice I have 2A and then plus b for that one. So as far as properties of vectors, there's a couple major properties that you need to know. So vectors can be moved parallel to themselves in the diagram. So I can pick up a vector and move it to a parallel position from the previous vector. In actuality, what we're actually doing is we're using the ability to place vectors next to each other so vectors can be placed head to tail. So going back to our example, so our a plus b, vector a is going up and ends on the coordinate 1, 4, so that's my arrow or my head. And notice that vector b starts at coordinate 1, 4, and then it goes down based off of the vector, and that's the value we end up at. So that's this idea of vectors can be placed head to tail. Vectors can be also added in any order. So you guys know what the commutative property of addition in math is. So you know that a plus b equals b plus a because the order does not matter. So same thing, vector a plus vector b is equal to vector b plus vector a. There's no difference in the order you add the vectors. So we alluded to this in the graphical slide. So we can also subtract vectors, or we can add the opposite. So simplest way to think about it, if I have a car moving 30 meters per second east, I would have a negative vector of negative 30 meters per second if I was subtracting it. So all you're doing is you're adding the opposite value. So my original vector was 30 meters per second. So my opposite value is going to be the negative version of that. So hopefully that makes sense. And we'll work through this in a problem set. Our last major thing, so multiplying, dividing vectors by scalars. So a vector that's multiplied by a scalar is still going to be a vector. A vector divided by a scalar is still going to be a vector. So with that being said, these concepts shouldn't be too hard. There's also going to be a video where I work through a couple problems and give you a problem set to work on your own. And we can visit some of those problems on Tuesday during class time. So I'm going to cut it here. That way we can get this video uploaded and jump into our practice problem video.